So coming to today's section on adopting Azure Durable Functions to build serverless stateful workflows, I have got an very popular Microsoft MVP, Jonah Anderson, with me.
Today, I will be sharing with you about adapting Azure Durable Functions to build your stateful workflows, specifically in Microsoft Azure. So before I start, I know that Essie has introduced me that this is about, I'm going to share a bit about myself. So I'm Jonah Anderson. I'm in Sweden. I work as an IT consultant at Forefront Consulting, working with different roles like software development, cloud development in Azure, and even full stack .NET and DevOps management. And outside work, I am very active in the community, as Essie mentioned, as a Microsoft MVP and Microsoft certified trainer, and the leader of and founder of Azure User Group Sweden. So today I'm planning to just go through serverless in Azure, Azure Functions, durable functions, the different patterns, common use case, hopefully if our time permits a demo, and some recommended learning resources. So maybe some of you have worked already with Azure Functions. So it's good. So this would be the basics and fundamentals, technical knowledge that you need to know. So I want to start this session with the problem, which is I encountered when I was studying Java development. It's called the dining philosopher's problem. And to those of you that probably have seen this before, this is pretty familiar. But to those that are new to this dining philosopher's problem, this is something that's commonly shown to you that are trying to understand concurrency problems. So, for example, in this like physical real world scenario, for example, if you have like 5 people or philosophers that are trying to eat in the table, and they're going to use chopsticks or spoon and fork, uh, whatever they use, but they would need to use the left and right in order to eat. So as you can see in this image or illustration, if one of them or if each of them starts picking the chopsticks from left to right, then that means they are not able to eat, or they will also encounter some problems, and they will experience deadlock and starvation. And deadlock means like just like in software development as well, like we encounter issues with that, and our programs or applications won't be able to do what it needs to do. And in this example, like if you see this image, deadlock can happen also in the real world scenario, especially if we don't have rules. Can you imagine crossing or a road in the traffic without any rules? There will be a deadlock. The people will get, I mean, our cars will get stuck in the middle. So this is my point for concurrency issues that I believe can be solved by Azure Functions or serverless solutions that we have today in the cloud. So racing conditions, deadlock, concurrency problems will be solved by serverless solutions. And for those of you that are new in serverless computing, serverless just literally means that you're abstracting the infrastructure and servers behind your applications. This means that the cloud provider like Microsoft Azure will take care of that for you so that you can automate your processes, you can break your logic into functions. You have the option to scale it automatically and integrate it with different services within the cloud platform, like Azure services, like for example, Azure Logic App, Azure Service Bus, and Azure Storage, and so much more. And one of the advantages of serverless is that the option of pay as you go, or the consumption model, to those that only want to pay for what they use for their specific instances. There is also an option for premium pricing model, but it actually depends on the use case scenario, especially if you want or prefer to do premium features on top of your serverless solutions. So I'm from Sweden, and we have this term called fika. And I did the serverless suite comparison from left to right, from monolithic to serverless, that describes how the difference about monolithic and serverless from left to right. So if you see here, monolithic, the old on-prem way of building applications, we have everything in one layer, just like the cake. So everything is in one infrastructure on-premise. This means that in the monolithic architecture, the old way that we're used to, this means that if the database server breaks or the application breaks, then it will affect our real users. So that's the monolithic. And then we have the microservices that isolate the service in order to handle them properly. And for example, in a microservice, you have something that handles the user management, the billing management, and the application, everything that you have, admin management. But the point of using a microservice is that if one of those services breaks, it doesn't affect the others, and that's how that's one of the advantages of using microservices. And then we also have containers, which is also an alternative options, like putting everything, your applications in containers, regardless of whatever like platform it is, if it's Linux, Windows. And it gives actually the flexibility of migrating easily to the cloud, because you don't have to change a lot in your like code base if you're putting everything in containers, because cloud providers provide that, like Azure has container options as well as like orchestration tools for that. And then the last thing to the right, we have serverless, which is like candies. They're small, which is easy actually to get started or implement if you're beginners of serverless. It means that you can code quickly a few lines of code to be able to send an email and integrate it with an API. And you don't have to worry about the infrastructure. But the point of my left to right comparison with all the sweets here is not to make you hungry, but also to point out the control versus the productivity that you gain in terms of implementing serverless in your solution compared to monolithic. So for example, the good old days, the good old ways that we're trying to get out of, from left, you see the monolithic here, the cake. It means that the more you stay, of course, the more you stay to the monolithic architecture, that means you have more control. However, the disadvantage of that is that you don't gain productivity. Your teams needs to work hard or uh, do everything instead of doing, I mean, taking care less of that infrastructure and take care of the business logic that needs to be delivered. And the more we go to the right, which is towards containers and serverless, you gain more productivity because you focus on the functionality and what needs to be delivered. And it also gives the advantage also of paying only for what you use, or the instance that's running in your production environments or environments that you have for dev or test. In terms of monolithic, you have to pay for the infrastructure while everything is running. So there's less flexibility in a monolithic architecture compared to serverless. And the most important part of it is that it gives our developers, like myself, productivity, not because we don't want to do coding, it's just like we want to be effective on a business logic that we want to do. That makes things easier for everybody, including those that are doing low code, no code solutions, which can be integrated with Azure Logic Apps. All right, so what is Azure Functions? So before we deep dive into Azure Durable Functions, we need to look first about what is Azure Functions. So Azure Functions, as you have seen, it's a compute service in Azure that is widely used by many, and it can be in a consumption model, and it's event driven, and it is focusing on the logic, as I mentioned, which gives productivity to developers working on it. And it can be integrated with other APIs, external ones, and other services within Azure, like Azure Logic App, Service Bus, and IoT services in the cloud. So basically, Azure Functions is composed of the code and logic that you write, and then the events or trigger that you use, and the data for input and output to be processed later on depending on your business scenario. And next one is the durable function. So durable functions is actually an extension. So it's built on top of Azure Functions. And this is ideal to use or recommended to use if you have business scenarios or problems that you want to be stateful and want to be orchestrated or written in a workflow by code. So I know that Azure Logic App actually allows us to write stateful workflows in the UI, but if you want to do it by code, then Durable Functions is an alternative solution for you. And what it does is that it helps manage and checkpoints the state for us. And that's because of the durable task framework behind it. And it can be coded in different languages like C Sharp, which I also code. Other languages like Python, PowerShell, and now recently they started supporting Java. So basically there are so this that you see here, so there's like this is like the components. So there's like the client function, which is like the starter or the event start, and then you have your orchestrator here where you write your workflow, which I will introduce later, the different patterns. And then the activities are the tasks that you are going to do or perform in your workflow. So in terms of supported languages, there are many actually. And I know that in terms of .NET, if you're working with Azure Functions or Durable Functions in .NET, C Sharp or F Sharp, there's two types of way. There's the in-process and out-of-process version. This one shows preview right now, but I think this screenshot was is not updated, but recently they started support for .NET 7 for out isolated process or out of process as well. So these are the tools or the supported languages, but check out the latest version through this link because they usually update this support for the versions and the language worker for this tool. And going back to durable functions, as mentioned, there are several types. So there's this client function that is actually used as it is used as a starting point of your orchestration. So your client function uh, is actually the one that triggers the orchestrator. So this means that you can have, for example, an Azure Blob trigger or Cosmos DB trigger as your client function. And that actually kickstarts your orchestrator functions. I said functions because you can have several orchestrators in one orchestrator. Because of the sub orchestrations. So in orchestrator functions, this is where you write your workflow, depending on the pattern that you're trying to write or trying to solve in your business scenarios or use case. This is where you write your logic, and this is also where you call your activity functions, which are the unit of tasks that you need to perform for the orchestrator. So they are like the typical standard Azure functions that we have in our serverless solutions in Azure Functions. And then there's also entity functions that's used for durable entities for .NET, which is also an alternative if you want to work with entities. And for me, I'm originally also from the Philippines, living in Sweden. So I consider the orchestrator in the durable functions orchestrator. It's like the Philippine dance in the Philippines. We have this dance in the Philippines called tinikling. Like the four people, two people have to move the bamboo, and then the two dancers need to synchronize with this bamboo steps. So I find the orchestrator as like this dance because it needs to be orchestrated, and there are some rules for the dance or for the orchestration to work. So the orchestrator, we talked about it. It's not just about the dance tinikling in the Philippine folk dance, but it is also an important type in the durable functions because he is our friend because he keeps our workflow stateful by managing the states and controlling it without us checking it manually. But he is also strict because when we write or author our workflow by code, he needs to be, or he or she needs to be deterministic. What does deterministic means? It means that it expects the same result all the time, especially when it replays. So the workflow will be replayed when it gets triggered again. So it is important that it follows its deterministic rule. So here on the left side, we see an example of a durable functions with an orchestrator. It's the one that's controlling the activities around it. And then there's also this, if you don't use like durable functions, you don't have an orchestrator, you can see that on the right is just like isolated Azure, standard Azure functions in there. So like, for example, if one of this Azure function probably is hosted in a different region or different resource group or logical container within Azure, and that region maybe is affected by an outage, that happens sometimes, that might affect your other functions, especially if they're integrated together. So it's good to have a workflow that will help you see what's going on in your orchestration, especially if you really need it to be stateful in handling business like functionalities in the production environment. And orchestrator. He's our friend, but he's strict. And this is the strict part that I'm talking about in terms of constraints. So there's a documented list of code constraints, which means the don'ts and the do's to take to keep in mind in terms of writing or authoring the orchestration. So for example, there's this on the red side, these are like the don'ts, like it's not recommended that you do the GUID random numbers within your orchestrator functions, and don't access your configuration or databases store from the orchestrator as well. Blocking APIs, infinite loops, and current datetime, the normal that we have in .NET, for example, we have this method for current datetime. And the reason why they are not allowed, because it breaks the rule of being deterministic. So if you see like random numbers, they are not deterministic. Like for example, database connection, they are not either. And then current datetime, infinite loops, especially. So what you can do, like for this examples, which is just a few of the constraints. So what you can do instead is there's an option in .NET at least. There's a new GUID method if you need to do random numbers or GUID. And then instead of having your configuration in the orchestrator function, you can have it in your activity function. So for example, if you have an activity that needs to send an email using, for example, SendGrid API or Twilio API, then you can have those database configuration or API keys as your configuration locally in your like activity functions. That's where you work on your local logic for that specific task or functionality that it needs to do. And then if you need, instead of using the common thread methods that we have, there's actually a method within the durable orchestration. It's called durable orchestration context. So the context that you have, that has a lot of methods in it. So you should be able to use this one in handling your synchronization or how you want your orchestration, if you want to delay or stop it or call a new instance, for example. And then infinite loops is highly not encouraged, especially in the workflow. I mean the orchestration workflow, because for example, it's not good because, as you said, you have an infinite loop and then it will be replayed as mentioned. So we cannot have that. There's a risk also that, for example, if you have something, an activity that's running instances and it is an infinite loop in orchestration that are replayed, so you can imagine that you have a risk of maybe getting high amount of bill in your subscription if we are not careful of that. So however, there's a solution for that. If you want to repeat something, there's a method under the durable orchestration context. This is specific to .NET, but it can be almost the same syntax for other languages. There's a method called create as new. So you can actually call another instance using that method. And then in the context as well, there's the current UTC datetime method that you can use instead of the default one in .NET, for example. So those are the patterns, the constraints. They're good to know, especially if you're just getting started. If you've done durable functions before, that's great. So this is just like a recap for you. But for the beginners, this is really important to think about in terms of stateful workflows. And you can read a lot of them. There's actually a list that Microsoft updates all the time. So this is the link here, and you can actually just search on Google durable functions code constraints, and you will get a lot of resources for you. And so now that we have learned the different types, what the orchestrator is, now we need to learn about the different patterns that you can do to solve complex problems using durable functions. So there are actually at least a max 6 that are documented right now in Microsoft Docs. And the first one is function chaining. And then the next one is fan out, fan in. And then there's the async HTTP API pattern. There's also the monitor pattern. There's the human interaction pattern, and there's the aggregator pattern. So they are the patterns that are recommended in simplifying complex stateful coordination requirements in any serverless applications or solutions that you're trying to do in Azure using this technology. So let's start with function chaining. So function chaining is basically as the term itself. So it's like a chain. So you have a first function, and then the second function. They are linked together. So basically, it's like it's a sequence of function. Like in this illustration, we have function 1, 2, 3, and 4, and it executes in sequence. So which means that if this is, for example, F1 is triggered by an HTTP trigger, and then you had passed in some parameters through that HTTP trigger, then you can pass that into your next activity function, so on and so forth. And of course, you can set your conditional statements within function chaining pattern as well. So function chaining in action uh, looks like this in the background. So for example, you have a trigger like, let's say, Cosmos DB trigger. So that starts your orchestrator. And let's just say that we have one or two, three activity tasks that we need to do. So once it gets triggered, the activity one is scheduled. And then what the orchestrator does is that it sleeps while the activity one is working with its task. And when activity one is done, the orchestrator wakes up and activity two starts working, gets scheduled, doing something scheduled. Activity two can be like sending emails or doing database operations from the data that was passed in. And then the orchestrator sleeps again. And then when activity two is done, then the orchestration is completed. But this is just a very simple one. There's just like two tasks and one run. And when it gets triggered again, for example, a new data comes in a Cosmos DB, it gets triggered, then it's gonna do the flow again. But this is just two activities, but it can be complex and wide or lots of activities running after it gets triggered. But my point why I'm saying this, I created this illustration is to show and tell you that with durable functions, when the orchestrator is sleeping, you are not actually being charged for the instances that are not running. So which means, so if activity one is the one, for example, activity one is the one that's scheduled to work, activity two shouldn't be running until it's his or her time to run. So basically, the orchestrator can be a sleepyhead, like my dog. I wish I could put a real video of my dog sleeping like this, but that's almost looked like him when he was a puppy. But the orchestrator can be a sleepyhead, but it is actually good because, as I mentioned, we don't pay for the instances that we're not using, especially if you're in a consumption model. So, which is a really good, especially or in the organization perspective. You don't need to, you have more control on what you want, which instances you want to run. And the function chaining example actually has this, like, this is a mini example that I had myself, which is currently a template on my GitHub. So for example, you have a blob trigger, and then it gets triggered and starts the orchestration or workflow. And in this one, I'm using function chaining. So I can pass in the blob image data when I upload an image to my blob storage. And then what it does, it can create or send a queue message to a service bus, which is another Azure service, enterprise messaging service in Azure. And then I can also like pass in any data that I want from that blob image, and send a message or make a call using another external API like Twilio and integrate it. And then you can also send email using SendGrids and other external email API. So the reason why I'm showing this to you, not just to illustrate function chaining pattern, but also to give you an example that with serverless solutions in Azure or even durable functions, you have the capability to integrate it or work with it using Azure services and external services like Twilio and SendGrid. So if you're curious about how this work, how it looked in the code, I actually have a GitHub public template for this example. Currently, I believe it's in .NET Core, but I'm in the process of updating it to .NET 7. So if you're interested to help me with that, feel free to contact me if you want. So the expected result of that example looks like this. So I have service bus, I got a queue message, I got an SMS, I got a message. I mean, I got a call. I got an SMS while I run. As you see there, I was running my functions behind, and I got it. I did have like a phone number on Twilio, so that's why it showed like I was in the American number. And then I got a call, and then I also got a message on my email through SendGrid. So this is just a very simple scenario, just for to give you a quick illustration, but this can be done in more complex scenarios using different Azure services or serverless patterns or solution. So the next one is the fan out, fan in, which is the second pattern. So in fan out, fan in, so as you can see here, you have your first function that gets triggered by any trigger that's supported, and then you have your you fan out, do several tasks at the same time, and then you aggregate the result as one. So this scenario is actually good if you're trying to do or perform tasks that requires it to run in parallel before you, and then you want to summarize the result and maybe process it later. Maybe one example, maybe if you want to process several orders, customer orders at the same time, and then you want to aggregate the result of that, or if you're calculating lots of data and then you want to aggregate the result, this is also another pattern. There are different ways for that, but the good thing about this is that it's stateful. The workflow controls it for you. The orchestrator, you are in control of your orchestrator for this pattern. And usually in a normal standard function, um, fanning out, maybe it's easy. Like for a normal function that's not stateful, fanning out is easy, but when you fan in, it will be hard because you need to make sure, you need to check, is this activity is done? Is this activity is done? It's hard to do that if it's not stateful. So that's the fan out, fan in pattern, and this is how it looks in C# code. So as you can see here, you have a fan out, fan in pattern. This is something that I borrowed an illustration or a copy, I mean, an example snippet that I copied from Microsoft Docs. So in the C# example that they have this like fan out, fan in example where you have a durable orchestration context. Let's just say you have a parallel task in here, and then you have a loop to go through all of the tasks, and then each task it's gonna call function to, and then it's gonna add it in that list of tasks, and then it's gonna aggregate the result and calling the third function, which actually just simply doing a sum of the result. So that's an example of C#. There are different examples in Java and other languages as well in JavaScript. So yeah, if you're getting started, there are good examples in Microsoft Docs as well. And then the third pattern is the async HTTP API patterns, which is very useful if you're trying to use durable functions for stateful long-running operations for API clients or external clients. So this is a good example. Like I have a very simple snippet here where I could actually, like I was using in a try-catch block, I was checking if my website, jonah.anderson.tech, is available, and just a few lines of code. I use this durable HTTP response instance, In my context, durable orchestration context, I called the method call HTTP async, and then I chose which method that I want, get, for example, and I passed in my website URL. And I have an if condition here that checks what's the status code or response that I get. And then depending on the response number, the HTTP code that I get, then I will process that response later or log it, whatever that I want to do with it. And this URL can be your API endpoint that you're trying to communicate with your or integrate with your applications that are already in the cloud or in production that you want to develop more with more features. And then the next pattern is actually monitor pattern. As the word itself, it's used for handling recurring process in a workflow, like for example, periodic job cleanup. In this example that we are trying to monitor the status of a job. And in a while loop, we kind of like set an expiration time for this. So you're checking on the status of your job, and you're getting your passing in your job ID here. And then when the job is completed, it's gonna send an alert. And then while it's doing its monitoring pattern, the orchestrator actually sleeps until it's time to check again. And that's what the pulling interval that you set in here on as your variable. And you can do a lot of things with the monitor pattern, like if you have something recurring that you want to monitor. And then the next pattern is the human interaction pattern. So for example, if you wanna like use durable functions to have a workflow that requires you to have a human interaction. For example, an approval process. So you have an order maybe that needs, or a request that needs to be approved by a person, and that person might not be available all the time. Maybe that person is on vacation, and but you have this process in your business. So what you can do, you can make use of the human interaction pattern in durable functions to automate a business process. And how is it done? So usually you add the durable timer in your approval workflow. So in this example, from the documentation that we have, specifically an example for C#, in an approval workflow, we are trying to use a timeout for this. So if you see, we have a due time. So we have a due of 72 hours, and there's a timeout here that checks if any happens, like if uh, approval happens or the timeout happens, then it's gonna process the approval. Otherwise, it needs to escalate. And this is just an example. There are many things or tasks in our business processes that actually require human interaction, like replying to an email or clicking on a button, approve. But that can be also automated using stateful workflows that we have for this pattern. And the aggregator pattern, it's basically used for stateful entities. This itself is very useful in many scenarios. So if you want to deep dive into durable functions entities, there's a big list of documentation and guide how to get started with this. But basically, it's used if you're working with entities, like for example, if you want to aggregate different event data that comes in different period of time, and you want to like put it in a single like addressable entity. And that this is an example that you see here. It's actually a event hub trigger in C#, and it's doing its stateful entities in terms of sensor events that's happening in an IoT device. So if you want to check it out, there's it's a bit of small text, but if one of the patterns is stateful entities, so there's good docs about that as well. And so those are the 6 patterns that we learned that's documented. But for me, I believe that we can create as many patterns as we want because of this option of sub-orchestration in durable functions. So as far as I know, it's currently supported in .NET, JavaScript, and Python. But basically what it does is that you can create like sub orchestrations as many as you want from your main orchestration. So you're extending your workflow. And this sub orchestration can be something that handles like a list or group of activities for your users, or maybe this sub orchestration is handling your orchestration for like a list of orders that you want to manage, or admin management. So so if you are interested, there's this option as well. And it actually looks like this by code. So you just basically call the method call sub orchestration or orchestrator async, and then passed in the name of your sub orchestrator function, and then whatever parameter or data that you want to pass into that sub orchestrator. And in this example, it's using the fan out, fan in pattern, because it's trying to like fan in everything that the sub orchestrators have done in the entire workflow. Yeah, so those are the important things. And now I'm just going to introduce you a bit about getting started. So if you want to develop more about Azure Functions or Durable Functions, so you can actually do it in the Azure portal or the Cloud Shell, and with any supported languages. Visual Studio and VS Code are the common tools that are used in Azure Functions, which is very good because you can develop locally. So you can literally work with use Azure Functions without even deploying it yet. And one thing that needs to be installed first in order for you to code develop it locally is download the Azure Functions core tools. And the latest version is something that you can find here on this link, or if you go to the Microsoft Docs site, it actually updates the latest version. So make sure that you have the latest to get all the features that you need for your serverless functions. And then I usually use Postman if I'm working with like HTTP requests and APIs. But there's also an extension actually in VS Code called HTTP REST client that you can literally call the endpoint or do HTTP requests by using that extension within your VS Code file. So check it out. I can share it also later in the chat or after the session if I get any contact from any of you. And also Azure Storage Explorer, as mentioned, Azure functions are integrated with Azure Storage. So that's where all your web jobs and histories are saved. And you can actually see those. I mean, whatever the Azure storage that's linked to your Azure functions, you can see it on the Azure portal, but you can also install the tool Azure Storage Explorer, which is actually free and very useful if you're trying to work with Azure storage in general. And also if you want to see what's going on behind your orchestration instances and web job logs in the storage account that you're linked to in your functions project. In terms of good to know, coding it, application insights, Azure Monitor for monitoring. I know that Serverless 360 also has a lot of tools for this in terms of monitoring serverless. So yeah, Essie can tell you more about it. There's also conscious versioning is also good to be mindful of, especially if you're updating something in production and it needs to be deployed. So side-by-side deployment is good. Um, Deployment slots, and also like key vault, using key vault and protecting your keys and secrets and configurations. And also Azure functions or durable functions can also be used in like infrastructure as code if you wanna use that in other tools. And in terms of error handling, you can handle errors using by calling the typical try-catch blocks. There's also durable functions monitor, durable timers, application insights. And if you want to take control of failure, there's a method for auto retry, and in .NET it's called call activity with retry async, which basically gives you the option through the context to pass in your retry configuration, and so you can handle what happens if this fails. So you can try to automatically retry, and you can actually call another activity to do its task if something fails. So that's a good way also to handle errors. And I think our time maybe is not enough, so I'm gonna skip the demo for now. And in terms of deployment, we have Azure Functions can be deployed to Windows, Linux, containers, set up the pipelines using GitHub Actions and the typical uh, DevOps pipelines we have, and infrastructure as code, bicep, everything to create the infrastructure. That's also good. And learning resources, these are the ones that I recommend. So follow Azure Functions blog or website, because they update things all the time in terms of integrations with .NET or other languages. And also, I recommend Azure Functions University by another Azure MVP, Mark Duker. He has this community of like developers that teach Azure Functions fundamentals and even advanced levels to the community. And if you want to get started and find out what are the projects that are available, what you can do with serverless, there's this community called serverless library.net, which is an Azure owned library where you see the projects, example projects by the community. And of course, learn by teaching. I myself was a mentor of Serverless Beat Project, teaching serverless to kids or younger. So if you want to learn, if you know something about serverless already, like share about it, speak, and just share it to those that are still beginning, and just share the advantages that it has, and how it can help with certain business scenarios. So I would like to end this session by saying that as a developer, I love serverless because it helped me solve complex problems, and I can build modern apps, and it also makes me productive. So thank you so much. If you want to connect with me after this webinar, feel free to scan the QR code or leave your questions to Essie, or I can also answer it after this one. Thank you so much. And that's actually my dog, Lawrence, that I was trying to show you. Thank you.
Thank you. Jenna, if you don't mind, can you please go ahead to the next slide, please? So that I'll introduce Serverless 360 to the attendees here. Thank you. Yes. So I'm Mary Lucy, the lead product consultant of Serverless 360, which is an advanced cloud management platform engineered for Microsoft Azure. So what we do is we are accelerating Azure adoption across global enterprises and helping them deal with Azure operations and helping them excel in their Azure operations. So here you see are the proud customers that we are serving in ensuring their total cost of ownership is reduced while building Azure integrations and supporting them in real time. So with Serverless 360, you can achieve the advanced observability across your integration, spotlight where exactly the problem is, and remediate it with much of reduced manual effort. So more on Serverless 360, you can request a demo. We would walk you through the product and help you get started from there.
Covey.co